Hello and welcome to the Lancaster Farming Industrial Hemp Podcast. My name is Eric Herlock and today's show is an Encore presentation. We're going to replay my interview with Dr. Ron Kander. He's a materials scientist professor at Thomas Jefferson University in Philadelphia, where he has been studying hemp as a raw material and trying to figure out how to get it into our systems of manufacturing. He's really fun to talk to. You will learn a lot and you will laugh a lot in this interview. The reason I am replaying an episode and not providing a new interview, this month I'm taking some time off to prep for our road trip that's happening at the end of this month. I'll have some more information about that at the end of this episode today, but we will take a quick sponsor break and then get into our Encore presentation of my interview with Dr. Ron Kander from Thomas Jefferson University. This Encore presentation is made possible in part by Hemp Harvest Works and Bish Enterprises. With over 40 years' experience innovating agricultural machinery to solve the complicated issues that farmers face with smart, inexpensive solutions, Bish Enterprises and Hemp Harvest Works provide growing and harvesting equipment for today's hemp producers. Focused on solutions for hemp farmers, whether they grow for flour, fiber, or grain, Hemp Harvest Works has the equipment and the experience to meet your needs. Go to hempharvestworks.com or call 402-849-2674 for a one-to-one equipment consultation. Dr. Ron Kander, welcome to the Lancaster Farming Industrial Hemp Podcast. Could you introduce yourself a little bit for us?
Sure. My name is Ron Kander, and I am the Dean of Kander College of Design, Engineering, and Commerce at Thomas Jefferson University. I'm also the Associate Provost for Applied Research at Jefferson.
And give us a little background on how you got to Jefferson.
Sure. So my background is in chemical engineering. I'm a chemical engineer by training, trained at Carnegie Mellon and University of Delaware. And when I graduated with my PhD at Delaware, I went to work for DuPont, like many Delaware PhDs do, and was an engineer there at the experimental station for a while, and then joined academia back in around 1990 at Virginia Tech in the material science department there. Was there for about 10 or 11 years, moved to James Madison University in Virginia for another 10 or so years, and came to Philadelphia about 8 years ago to start this new college, Kander College, at what was at the time Philadelphia University, which has in the last 2 years merged with Jefferson.
Okay. And so material science, you're making the things that other people then make stuff out of, or how does that work?
Yeah, I often describe it as things are made out of stuff, and we make the stuff that things are made out of. Exactly. So we basically, material scientists study the process, structure, property, relationships of materials. Okay. So how do you process them? How does that processing change their structure? And how does that structure change their performance and their properties in an application?
So I imagine you have some key information in regards to industrial hemp and what this industry can do with this raw material.
Yes, that's been one of our key research areas over the last 2 years.
Okay, before we get into that, tell me how you first got into hemp in the first place.
It's very interesting. So a donor came to the university, a philanthropist out of Australia, actually, because he was interested in the medicinal applications of cannabis, specifically. And he donated a significant amount of money and formed his name was Barry Lambert, formed the Lambert Center for the Study of Medicinal Cannabis and Hemp at Jefferson, downtown in the medical arena, in the clinical area.
Okay.
And but very early in that relationship, it was after we had merged, and it was pretty obvious that you had to look at the entire plant and think about all the other applications for hemp as a plant, not marijuana, but the hemp plant, and what it could be used for in industrial and consumer products, because the market size there was huge compared to the medicinal applications. So some of the funds and some of the research focus then shifted to our campus in East Falls, where we started looking at hemp as a plant rather than medicinal applications of cannabis.
And what sorts of research projects are the students at Jefferson and your colleagues working on?
So we have a very interesting approach to the research here. It's sort of what I call a tripartite research study. We have engineering and science students who are looking at the material science of hemp as a material, as I described a minute ago.
Mm-hmm.
We also then have design students from programs like industrial design and textile design looking at product design and development. And then we also have students in the business school looking at sustainability and supply chain economics of processes for the hemp business. So that's why our college is kind of uniquely positioned, because I have design majors, engineering majors, and business majors in a single college.
Do you really ever get a chance in industry to design an industry from the sort of start to finish?
Yeah, we don't. I mean, that's what's so neat about this is, and we're unique in the world in a sense that the United States has artificially been preventing this industry from growing on the industrial and consumer side, while the rest of the world hasn't. So we're somewhere between 50 and 100 years behind the world in developing an industry. So it's the cool part of this is how do you start from essentially scratch and build it to compete on the world stage, but do it in a way that it remains economically viable and competitive along the way.
Right. So how do you do that?
Well, that's a good question. So you have to start with, in my opinion, the industrial and consumer product side of the business at least. You have to find some high value, low volume products that can use hemp as a biomass.
Mm-hmm.
So that you can start developing processes that then let you put that material into consumer products and industrial products and show a value chain. And then that will allow you to then grow volume and look at larger applications down the line. So for example, one of my very best friends from graduate school is a vice president at Georgia Pacific. And of course, they make paper and cardboard.
Mm-hmm.
They've clearly looked at hemp as a material, as a raw material over the years. So when we started this project, I called him and asked, where do they stand? And he sort of jokingly said, "Oh yeah, we think it's a great material. Show me a stable 100 million pound a year supply chain, and we're in." So you don't start with a Georgia Pacific as how you build the business, right? So you need those applications. On the other extreme, our students have done calculations. We've picked a hypothetical applications and said, if you went backwards from those applications, could you build a business?
Yeah.
So, for example, one of the materials we've patented has some very nice sort of anti-odor and antibacterial properties.
Okay.
And it can be incorporated into textile fibers to make things like sportswear.
Right. Okay.
Either for athletes or even first responders who need performance textiles.
Right.
So imagine, if you will, for example, something like yoga pants.
Okay.
If you look at the cost of a pair of high-end yoga pants at a Lululemon or wherever, and you go backwards from the cost of those pants to the profit that the company makes that sells it, and go backwards and look at the cost of materials to support that business and how much of it would be a hemp-derived material, and go backwards through the processes to how many acres of hemp field would you need to support, say, a $50 million business in yoga pants.
Okay.
And because it's a high value product, we're talking about a few hundreds of acres. You're not talking about needing tens of thousands of acres. You don't need the entire Midwest growing hemp to support a small business like that.
Okay.
Now that's just one example, but so the idea is, can you find a few dozen of those applications and then, build your little Lego blocks and build up then a business around those until you can get to larger volume.
So what is it about the plant that makes it appealing to you as a materials engineer?
So it's interesting you should ask that question. So one of the analogies I've often made about this plant is what we need in hemp is the equivalent of a refinery in the oil industry. And what I mean by that is, if you pull crude oil out of the ground and all you did was make gasoline, there's no business model that shows you an economics that says it's worth pulling the oil out of the ground if that's the only product you make.
Okay.
The purpose of a refinery, if you think about it, is to take that crude oil and fractionate it out into 15 or 20 different products.
Right.
so that those can be sold into different industries as raw materials for then a bunch of different products and services. So now the collective economics of that product suite makes it worth pulling the oil out of the ground, right?
Right.
That's the business model.
Right.
So the same thing has to be done for the hemp plant. Is as a material scientist, the real interesting thing is you can take that plant out of the ground at the farm and ask the question, what processes would you need to do to that plant to put it into a form that is easy to transport and has attractive material properties and is ubiquitous enough to use in the form you have it in, that it could go out to multiple industries. And there might be 3 or 4 things you fractionate off of the plant to do that with.
Okay.
And then you can now start building an industry around that suite of products that makes it worth growing and harvesting and processing the plant.
Now, is that sort of theoretical, or does that technology exist?
Interestingly enough, the exciting thing about this is there's no step in that process, in those processes, that doesn't already exist commercially at large scale.
Okay.
So again, because these industries have been happening all over the world for years, so there's equipment that can pull the plants out of the ground. There's decortication equipment that can strip the fibers from the herd, from the flowers, and from the seeds. So the equipment exists. And then what nobody has really done is taken the higher volume parts of the plant, like the herd, which is the woody part of the plant that's left after you strip off the fibers and everything else,
Mm-hmm.
the stalk, if you will.
Right.
That material has traditionally not been used for very many high value products. A lot of times it's chopped up and just used as animal bedding,
Right.
for example. I've joked before that, building a business model around something where 85% of your product horses pee on might not be a really robust business model, So, one of the first questions we're asking is, can we take that high volume material and come up with higher value applications? So can I process it into a traditional form where it can be used by a bunch of industries?
Okay.
And then adding that value all of a sudden flips the value proposition for all the other parts of the plant that are useful for other applications, the CBD oils, et cetera, et cetera.
Right.
And all the processes exist. It's the patents that we've developed here in conjunction with our industry partners have all been around taking existing processes and chaining them together in unique ways to process the hemp plant.
And there's a lot of talk around hemp that it sort of needs local supply chains. What is it about the plant that makes local supply chains important or necessary?
Again, a very good question. It's kind of counterintuitive to somebody that's not in the field, but the denser a material is, the cheaper it is to ship. Because shipping is actually by volume, not by mass.
Okay.
So this is why steel, for example, there's an economics around making steel in China and shipping it to the United States to be used, because it's such a dense material that per pound, it's relatively inexpensive to ship.
Okay.
The hemp plant is exactly the opposite. When you pull it out of the ground, you can't pack it together very densely. It's a fluffy material.
Mm-hmm.
So you can't put a lot of mass in, say, a truck to ship it long distances. Your price per pound is very high. So there's a driving force to put the processing plants relatively close to the farms, so that you minimize the economic impact and the environmental impact of all that transportation. Because the plant out of the ground is in the farm, in the ground, it's a carbon negative plant. It actually sequesters more carbon from the atmosphere than it takes to grow it.
Yeah.
So the challenge is, once you pull it out of the ground, all the things you need to do with it to put it in a product, can we keep that sustainable enough so we don't lose the advantage of that growing process?
You mentioned the environmental impact. How important is it that manufacturing sort of gets on board with the carbon neutral or even carbon negative technology? How is it important that they get on that soon? Are we running out of time?
Yeah, I think it is incredibly important that they get onto that soon. I often tell my students and other folks when I talk about hemp as a material, I mean, this is true for all materials, but specifically our discussion today, there are really 4 things you can use in developing a new material like this. It has to have either it outperforms incumbent materials in its applications, or it is cheaper than incumbent materials in its applications, or it is more sustainable as a material compared to its competition,
Mm-hmm.
or the fourth one, which a lot of people don't think about, is it has a more compelling marketing message than other materials. So, in fact, if you're developing a new material or a new product, you want more than one of these things to be an attribute you can leverage.
Right.
So hemp actually has all four of those in different markets, not
Yeah.
all necessarily all at the same time in all markets, but it definitely, there are some applications where it can outperform other materials. It is a relatively inexpensive renewable source of biomass, so it could be cheaper than other biomasses. It clearly has a sustainability advantage over a lot of other materials, especially wood. And then if you have to keep supply chains local and you have a carbon negative material, there are really compelling marketing messages you can use around products you've made from locally grown sustainable materials from regional industries.
Mm-hmm.
So all four of those I think are important. So and a reason I make the argument that way is you can make the sustainability argument from a saving the planet point of view, and there are many people in the world, including myself, that agree with and support that. But it's difficult to go to a corporation and say, you should do this because you're going to feel good about yourself when you're done. So you have to have some compelling economic argument or marketing argument that says there's a really good business reason.
Right, because they're looking at
if,
the short-term profits. Yeah.
Right.
Yeah.
And it's easy in this case because if I develop a process that uses less energy, uses less material, and generates less waste, the odds are pretty strong I've also developed something that puts you in a favorable economic position.
Yeah. And then I imagine if these, the local supply chains are in place, that would bring jobs to a lot of places where there aren't a lot of jobs, right? Like this could be.
Absolutely.
Yeah. Hey, hold on one sec.
Yeah.
I'm going to let the dog out here. See you, buddy.
Sure.
We'll edit that part out.
Well, we've answered that eternal question about who let the dog out.
It was
Very
me.
Good. Now we know.
It was me.
It was you.
Yeah. So as hemp ramps up, could it be sort of like dropped into existing manufacturing technology, or do many industries, would they need to retool?
Therein lies the great question. So the point of our research, one of the points of our research, is to think about processes that will transform hemp into material forms that can be used in existing industry equipment.
Mm-hmm.
So rather than forcing industries to retool, now there will be some equipment necessary to get it from the farm to that form.
Okay.
But I think that's where the initial investment needs to be made, and that's where either consortia from industry or state and federal money for workforce development would be really well applied right now, is to put processing plants in regions where there's potential to use hemp as a high value product to grow.
Yeah.
And our goal would be to design processes so that what comes out the end of that local processing plant is something that you could ship to many different industries for use as a material form. So it's a very ubiquitous form of material.
Right. And what would that form look like?
So there's a couple options. So one could be putting the hemp material into polymers and making like injection molding pellets and fibers, either for 3D printers or for injection molded plastic parts, especially if you use biodegradable polymers made from biomass also.
Okay.
There's fabrics. There's woven and non-woven fabrics that you can make from these materials that could then be subsequently used in other applications, everywhere from apparel to geotextiles. So those are just some examples of things you can do to get it in a form that other industries know how to use already.
Right. Okay. In other industries, let's say the oil industry, there's unintended consequences from that manufacturing. Can you foresee any unintended consequences from a strong hemp industry?
That's a good question. So the material that we're talking about is a renewable biomass that grows very, very rapidly. So there's really not a lot of like waste materials that are going to be made available. I guess depending on the processes we use, there's a chance you might at some point in a process have to use a chemical or something that might be more dangerous. So we're trying to avoid that in any of our processes
Mm-hmm.
right now. Um, the only real one is it's the opportunity cost of the land necessary to grow the hemp, right? If you really develop a super robust market for hemp as a raw material, and it's of high enough value, you might find farmers choosing to grow it instead of food crops.
Mm.
Now, we're not anywhere near that yet,
Right.
but I guess long term, there's an opportunity cost associated with the acreage that could be an issue someday.
Right.
It's not as big a deal as it is with, say, corn,
Right.
where corn is a direct competitor for food, right? So if you're using corn to make ethanol or using corn fibers to make biodegradable polymers, you're one for one replacing corn that could have been used for either animal feed or human feed.
Right.
The hemp plant, since it has such a short growing cycle of 100 days or so, could be a rotational plant. So you might have somebody still growing their normal food crop, and then between food crops, they grow, 100 days of hemp.
Right.
So
Hemp could be a food crop too. I mean, they say the hemp
true.
seeds are a superfood.
Yeah.
And I guess
very good source of protein. Very, very good source of protein.
Yeah, and you hear about these like dual purpose crops where you could grow for the fiber and the bast, and then still get seeds from it. So maybe.
Yep.
I don't know.
Mm-hmm.
Yeah.
Yeah, that goes back to this refinery model, right?
Right.
You grow the right plant or mixture of plants in your fields, so that you can bring them all to the centralized processing plant and strip out seed and fiber and hurd and leaves and all that stuff.
Yeah. How about for farmers? Any advice for farmers? I always ask people on the show how farmers can avoid getting the short end of the stick when it comes to industrial hemp.
Yeah.
Any thoughts on that?
So we've been trying to work closely with the Penn State Lancaster Center and starting to talk to them about the ag and extension component of education and workforce development associated with hemp as a new crop.
Mm-hmm.
I shouldn't say new, but new now.
Right.
So I think there are. So there's a couple strategies. I think farmers will need to go in with their eyes wide open to this. I think there's two obvious strategies that they should consider. Let me preface that by saying farmers are way smarter than me. They're one of the most. It's one of the most savviest businesses. I mean, you really have to know. You have to be a very good business person to survive in that business.
Right.
But two things from the outside that I see are, like I said, processing. I think there's two strategies there. Either you're going to see consortiums form or co-op type arrangements form so that they can share the cost of processing,
Okay.
Which would lower the expense of getting the material into a form that's usable in industry. And or you will see farmers vertically integrating into the processing so that they can capture the processing value and the plant value.
They would have processors right on their farm.
Right. Or two or three farms get together and, start a business, which is a separate company but is co-owned by the farmers, and it is their processing facility.
Got it.
I think about it a lot of ways like the tobacco industry grew up in the South. The drying sheds were typically co-ops where, farmers in a region got together, they built one drying shed and they shared it in a business arrangement so that they could dry and sell, from there,
right,
from all the farms. So, I mean, I think, that's a good metaphor for one option is to vertically integrate and then co-op together to capture the processing costs.
Okay.
And I think the other thing is there's going to be some regionalization of this because different species and varietals grow better in different parts of the country.
Right.
So I think that's another reason localization and diversification I think is going to happen is that the plants that grow best in Pennsylvania, we still need to determine which varieties are those and what suite of products are they best for.
Mm-hmm.
So we may be supplying markets the way different than say Kentucky is or Virginia is or out west is. So that's another strategy they have to think through.
Right. Yeah, I know there's a bunch of plant breeders here in Pennsylvania who are working on that very thing.
Right.
When people talk about industrial hemp, they always sort of leap to bioplastics. Um,
Hmm.
how how close is that to a reality?
Actually, very close because that technology again already exists. We know how to make bioplastics from corn and switchgrass
Hmm.
and soybean plants and stuff. So it's just a matter of repurposing those technologies to the unique nature of hemp as a biomass. And I know that some of my colleagues at Lehigh have started looking at that in terms of how that might be used. And then you really start to get interesting because if we can use the reinforcing component as a hemp derived material and the biodegradable polymer made from hemp, then you actually could make both the matrix and the reinforcement in a composite material out of hemp, and the whole thing would be compostable or biodegradable.
But so what do you need? You need like consumer demand for that, or how does that switch get flipped?
I think that the trick to get that started is to not try to change consumer demand. It's to identify the products that you could substitute in a hemp derived material for the existing incumbent material and beat it on two or three of those four elements I
Right.
discussed.
Right. Okay.
So, because I think that's the way to enter the market. And then once there's some products out there that are branded as hemp derived materials, now you start leveraging the brand.
Right.
So now maybe you could have something that maybe is a little bit more expensive as a premium product, and people will buy it.
Right. Um, Speaking of the hemp brand, there's sort of a negative stigma around marijuana. Do you think that matters anymore?
It's starting to change, but it's still an issue. Every time, every group of students that we put onto these projects, the very first thing we talk about with them is what's the difference between hemp and marijuana? Um, what are we working with? How is that different? And how are you going to explain that to your grandma at Thanksgiving when she is concerned because you're working with hemp at school?
Right.
Um, and I jokingly said metaphorically we have a swear jar here that is sort of the equivalent of a swear jar, right? Anytime you make a pot joke on a hemp project, you have to put $1 in the jar because we're trying to change that behavior. They're two different things, so you don't compare them to one another.
Right. Yep. Yep. Yeah. With
But I think people get it now, but there's still that, somebody wants to make a joke,
yeah.
right?
Yep. Um, in an ideal world, what would the hemp industry look like in 20 years?
Wow. So what I'd like to see is we have a network of farmers across the country growing a wide range of varieties of plants for different reasons. There are regionalized processing centers that are producing intermediate materials in each of the regions for different kinds of markets. And then we have a really robust distribution network that allows that processed material to be distributed to wherever it needs to go to make new products. Um, None of the other countries that are strong in hemp are doing that. Um, the smaller countries have specialized uses for hemp, but the United States is large enough and has a large enough agriculture infrastructure
Mm-hmm.
that we could actually be the location for diversified growing and production of products from hemp derived materials.
There you go. There was a guest on our show last year, a guy named Bruce Dietzen. He builds sports cars out of hemp. The bodies of them, sort of in the the Henry Ford style.
Yeah.
And he talks a lot about carbon negative technology, and his idea is that we just need to build as much as we can out of hemp. It takes the carbon out of the atmosphere while it's growing, and then we can lock it up into products. Is that feasible?
I mean, it is. You have to look at the entire system dynamics, though. Doing that, and I'll use the extreme example. So if you take hemp out of the ground and you do so much sophisticated processing to that you cause so much environmental damage in the processing that you wipe out the advantage of growing it,
Right.
then you haven't done anything. The the analogy here is electric cars, right? When an electric car, people say is a zero emission vehicle,
Yes,
and
but
it's not. It's not, because for two reasons, right? The electricity it uses got generated somewhere.
right.
If that's a coal-fired plant, then it's generating CO2. But also, the battery had to be manufactured, the frame had to be manufactured, everything in the car had to be manufactured, and all of those businesses and processes generated waste.
Right.
So the vehicle in its life cycle is not a zero-emission vehicle. Now, you could argue that centralized point sources of emissions are better than distributed, so maybe it is better to have one power plant generating all the electricity and distributing it to the cars. But you have to do that systems analysis. You can't just assume, because nothing's coming out of the tailpipe,
Right.
that it's a zero-emission vehicle. Same thing here is, hemp's a great material, but depending on what I do with it in its life cycle, it could be just as damaging as anything else.
Right. Does your research team, do they look at nanosheet technology where hemp has, sort of electrical properties?
Yes, that's one of the material forms that we're pursuing, absolutely.
Okay.
And looking at it as a nanomaterial, and in several forms. There are a very common thing that's made from biomass over the years is a material called cellulose nanocrystals, or CNCs. And it's a process of removing the lignin from biomass and having left behind the crystalline cellulose.
Wow.
And that ends up being very, nanoscale, little like needles, sort of, that have very high aspect ratio, very good length compared to their diameter, and are very effective as reinforcing agents. And if you carbonize those materials, they would be conductive too. So you can imagine both mechanical and electrical properties from those nanocrystals.
Yeah.
And that's a good example of taking something like hurd and doing something very high end with it that gives you some very high value applications, even if they are small volume.
Right. That's fascinating. It sounds like you have a super fun job, because you just get to, research and just use your imagination.
Oh, absolutely. I've always said being at the university sure beats having a real job.
That's great. Is there anything else you want to talk about, or that I'm forgetting to ask you?
Well, I'll just say that the last point we made about the cellulose nanocrystals,
Mm-hmm.
Another amazing thing there is that, again, you're talking about existing processes. So it's not like cellulose nanocrystals were invented last month. People have been making CNCs out of other biomasses for years.
Okay.
So we know it's doable. So it's not going to be, rocket science to put together the right processing steps to take, say, a hemp hurd or hemp derived material and generate something like a CNC from it if you wanted to. Now we need to test the process economics of that, but my guess is hemp is such an efficient biomass to grow, right? You get so much biomass per acre
Mm-hmm.
because of the height of the plant and the density that you grow them at, that almost any existing biomass application you could substitute in hemp probably and show that there's an economic advantage.
If people are interested in reaching out to you for your expertise, or, to learn more about, the industrial uses of hemp, what's the best path for them?
I'd be glad to have them email me. That's no problem at all. They can find me on the Jefferson University website. My email address is simply my name, Ronald.Kander, Kander, @jefferson.edu. And I'd be glad to hear from folks if they have questions or would like more information.
All right. Dr. Ron Kander, I appreciate your expertise and your imagination and your candor. Thanks for joining us today.
Thank you very much. It was great.
All right, well, I hope you enjoyed this Encore presentation of the conversation with Dr. Ron Kander. He is so much fun to talk to, and if you've ever met him in person, you know that he's a super great guy to talk to in person too. So anyway, hope you enjoyed it. So I mentioned something about a road trip. It's true, we're going on a road trip at the end of June. We're taking an RV, we're going all over the place. We're going to take 40 days and travel the country. Headed first to North Carolina, then Kentucky, then Kansas, then Colorado. So yeah, if you see our van heading through your town, be sure to give us a wave. If you want to learn more about the tour and how maybe you can get involved, please drop me a line, send an email to podcast@lancasterfarming.com. And be sure to check out lancasterfarming.com during the course of our tour, because I will be publishing all sorts of extra stuff there, videos of the people I'm interviewing, extended interviews of things that don't make it into the actual podcast episodes, lots of photos, all kinds of stuff. So, all right. And I will be publishing weekly updates in the newspaper too. So you can follow along in the paper too. So, all right. My name is Eric Herlock. I am the digital editor at Lancaster Farming newspaper, the greatest agricultural newspaper in the world. So until next time, I'll see you in the newspaper.
Industrial Hemp.
Episode 135 of the Lancaster Farming Industrial Hemp Podcast is copyright 2021 by Lancaster Farming newspaper, part of the Steinman Communications family. The show was written, recorded, edited, and produced by Eric Herlock. The strange and enchanting music you hear throughout the show is courtesy of Tin Bird Shadow.